Today we'll be looking at lesson 2.8 on literal equations and dimensional analysis. Basically, we're going to be solving equations for different variables and also trying to convert things like miles per hour to meters per second. And we have an example of all of these to do. Here we're asked to solve each equation for the variable indicated. So they gave us 15 equals 3n plus 6p, and we are solving for n. So if we're solving for a particular variable, we want to cancel out everything but that variable, so that variable is by itself on one side of the equal sign and everything else is away from it. So we're trying to solve for n here, so we need to first look at what's not directly with the n, but the 6p. We want to take that entire term and move it to the other side so that it's away from the n. So we're going to subtract it. That'll cancel it out from the right side and bring it over to the left side. And I'm rewriting each new step. So I have 15 minus 6p now on the left side equals 3n. So the only thing left to do is to divide out the 3 so that we'd have just the n. And this is 3 times n, so that's why we're dividing. So our answer would be n equals 15 minus 6p over 3. Now you can leave it like this, or if you are able to simplify both of the numerators, then you can also rewrite it to be 5 minus 2p, and this would be more simplified. All I did was divide 15 divided by 3 to get 5, and 6p divided by 3 to get 2p. So I have 5 minus 2p. So that would be our final answer. Now this one we are going to solve for k. So we need to cancel out the 5, and we also need to cancel out the minus 2. So I'm going to start with the denominator. That would mean I would multiply, since that's divide by 5. So I'm going to multiply by 5 on both sides. Now I have k minus 2 equals 55j, because I did 11 times 5. Then I would just need to cancel out the 2 to have k by itself, so I would add, and I get k equals 55j plus 2. And that would be my final answer. Here's another one. You're solving for t. So we want to get r plus 4 away. Since this is grouped together and it's t times r plus 4, we would need to divide out the r plus 4, and we can keep it grouped together, and divide out the r plus 4, and that cancels everything out except for the t. So my answer would be 28 over r plus 4. And now since we can't do 28 divided by r and 28 divided by 4, we're not going to simplify this anymore. So we would just leave this as 28 over r plus 4. Here we're solving for q. So we have an a that we need to cancel out, and then we need to cancel out the minus 8. So I'm going to divide by a first. I always start with what's not directly with the variable. So I'm going to divide out the a, because that was multiplication. I get q minus 8 equals 23 over a. And then I just want to eliminate the 8 so that q is by itself. So I'm going to add 8 to both sides. So I get 23 over a plus 8. And that would be my final answer. Here's one more. This time we have, we're solving for d, but we have a d on each side. So if you have a d to combine with another d, in this case you're going to do that first. So I'm going to combine the d with the 3D. And I'm going to subtract it from here and bring it over to be with the 3D. So I have 5c equals 3 minus 1d, which is 2d minus 1. And now I have the d's together so that I can cancel out everything that's not the d. So I want d by itself now. I want to cancel out the 1 by subtracting, adding. And then I have 5c plus 1 equals 2d. And then I'm going to cancel out the 2 by dividing. So my final answer would be 5c plus 1 over 2. And that would be equal to d. Okay, for some reason, again, it paused on me without me knowing. So I'm going to go back to the other slide just in case you missed this explanation. So what I did first was I divided out the a because I'm solving for q. And then I would add 8 to both sides to get q by itself, and then my final answer would be listed here. And my next one that I just did, I would have to combine the d's first because there's 2 d terms. So I would combine the d's first and then start eliminating everything with the d. So I have d by itself, which is what I continued to do. So I subtracted d first to bring it over to the 3d, and it gave me 2d. And then I'm going to add the 1 on the side with the d to cancel out the 1. I have 5c plus 1 equals 2d, and then I would divide out the 2. So my final answer would be 5c plus 1 over 2 equals d. And since I can't simplify 5 over 2 or 1 over 2 any more than it is, I would leave it the way that it's set up here. And this would be my final one that we're going to do with formulas, or with solving for the variable. They call these literal equations. So we're going to solve for q, and we need to combine the q with the other q. So I have 6q minus 18 equals qr plus t. So the first thing I'm going to do is I need to divide out the q, which would be here. So that I separate it from the r, and I'm going to get 6q over q, which is like 6q over 1q. It actually becomes just 6. So I have 6 minus 18 equals r plus t. And the 6 minus the 18 would give me negative 12 equals r plus t. And that is about as simplified as I can get it because the q's have canceled themselves out. Here we're going to solve for a particular letter in a formula. Normally the formula for the volume of a rectangular prism is V equals L times W times H, where L is the length, W is the width, and H is the height. We're going to solve the formula for W. So we want to eliminate the L and the H. So since it's all multiplication here, we can actually group the L and the H together and just divide them both out at the same time. So I end up with V over L times H equals W. And then I'm going to use this for the next problem. So if we remember that V over LH equals W, we have V over LH equals W. This question is asking me to find the width, so find W of a rectangular prism, and it gives me all the other parts. So the volume is 79.04. We're going to plug that in for V. And then length is going to be 5.2, so we plug that in for L. and the height is 4, so we plug that in for h. And we're going to use order of operations here, so we did 79.04, excuse me, divided by, and we have to do 5.2 times 4 first. So 5.2 times 4 gives me 20.08. I'm sorry, 20.80. And I'm going to divide 79.04 divided by 20.8. And that gives me 3.8. And that's W. And the last problem, this is what's called dimensional analysis, where we are changing the units. And it wants us to change 100 feet in about 2.8 seconds to the miles per hour. So the car travels a distance of 100 feet in about 2.8 seconds. What is the velocity, or how much does the car travel in miles per hour? So we're going to change feet per second here to miles per hour. So to do this, I'm going to set up a ratio, 100 feet over 2.8 seconds. And I'm going to include the units, because that will help me. I forgot here. 2.8, okay. 2.8 seconds. And what I need to change it to is miles per hour. So I'm going to change each unit individually first, and then my answer will finally be in miles per hour. So let's say I were to change the feet to miles. I would need to think about the conversion of feet to miles. So there are 5,280 feet in 1 mile. So I only have 100 feet here. So I need to think about what would I need to do to convert feet to miles. And I would need to divide by 5,280 feet. Notice also that I put 5,280 feet on the numerator, and my denominator is 1. The other reason why I would do that is because I want the feet, the units themselves, to cancel out. So they would have to be 1 as the numerator and 1 as the denominator to do that. So that also will tell me where to put the feet. So this is 1 mile over 5,280 feet. Now we're going to worry about the seconds, and we haven't quite finished yet, so I'm not going to do any multiplying yet. But I want to change seconds to hours, so think about how many seconds are in 1 hour. There's 3,600, because there's 60 seconds in a minute, and there's 60 minutes in an hour. So 60 times 60 gives me 3,600. So 3,600 seconds in 1 hour. I want to cancel out the seconds. So I'm going to put the seconds, this time, on top. With the hours on the bottom. So in this case, 3,600 seconds over 1 hour. And all this is going to be multiplied together. But what this does is, since the seconds here are in the denominator and these are in the numerator, you can cross out the actual units. So you can see now we only have units of miles and hours, but now we just need to do the multiplication. So we have 100 times 1 times 3,600 is going to give us our answer for the numerator, which gives me 360,000 as my numerator. And then my denominator was 2.8 times 5,280 times 1. and that's 14,784. Now it wanted us to round, I believe, to the nearest whole number, so I'm going to divide 360,000 by 14,784, which gives me about 24.35. So I would say that's about 24, and that would be 24 miles per hour. As my, I don't know why it keeps pausing on me, but again, I'm sorry. My answer, I'm not sure when it started pausing, but my answer is 24 miles per hour. Just to review here, I set up, and I'm going to focus on each unit one at a time. So I set up in the beginning 100 feet over 2.8 seconds. We need to change that to miles per hour. So I made my next